we've really been focused on connecting new infrastructure to the grid, not expanding the grid itself.
Most transmission projects are really an access road project with a transmission component.
One of the biggest problems in our industry right now is we can't build capacity fast enough to keep up with our rapid demand growth.
No two transmission projects are the same as well.
Most of our grid was built in the mid 1900s, right?
More and more power going longer and longer distances. You need higher voltages to get it there.
This industry is booming, and really it doesn't appear to be cooling down anytime soon.
Welcome back to Power Perspectives. I'm Kinsey Grant Baker, and it is time to dive in. The whole once-in-a-generation demand spike thing means more than just stressed-out utility leaders. It has tons of second and third-order impacts that are shifting conversations across the power industry. How are data centers cooled? What comes first for utilities that need to build new infrastructure and update existing poles and wires? And the one we're exploring today, as transmission demand grows and utilities build more extra high-voltage lines, the industry is revisiting an old question with new urgency. Should the structure be a lattice tower or a steel pole? Today, I am thrilled to welcome two powerhouse guests, Zach Brinker, Senior Project Engineer at Burns & McDonnell, Brandon Goodwin, Technical Manager for Overhead Transmission at Burns & McDonnell. We are going to hear about what their comparisons show, why the answer to that big question I mentioned depends on more than just material cost, and how utilities can make better structure choices based on things like terrain, outage constraints, and the realities of construction. This is a blueprint for one of the tougher calls utilities are making these days, so buckle up and let's jump in. And before we do, a real quick note, today's episode is brought to you by our fantastic partners at Burns & McDonnell, so stick around to hear more about the work that they are doing a little later in the conversation. For now, Brandon, Zach, welcome to Power Perspectives. How are you today?
Doing good. Thank you for having us.
Same here. Thank you.
Of course. We're thrilled to have you here. It's going to be a great conversation. I think before we dive into the topic, I would love if you would both just introduce yourselves a little so our audience can get to know your voices if they're just listening in. I would love to hear a little bit more about maybe, what you do, what some of your biggest priorities are on your teams these days. Tell me a little bit more about the work.
Yeah, for sure. So first of all, Brandon Goodwin, I am the technical manager of our overhead transmission group in Kansas City. So I'm overseeing our technical professionals that are executing these design projects for major transmission lines across the United States and the world, really. So just kind of a background on me and how I got to where I am today. So it all started growing up on a family farm in rural Missouri, where I really loved coming up with an idea, figuring out, drawing it on paper, figuring out how it's going to come together, and then building it. And that's really where my interest in civil engineering first all started. And from there, went to civil engineering school for college. Really wanted to go build, the coolest bridge or the tallest building, like most civil engineers do, and had no idea of what the transmission line industry was or what it could offer for a career. During my college years, I did multiple internships with DOTs, again, in the basic civil engineering infrastructure world. And then I decided I was going to go back and get my master's. And between my bachelor's and master's, I took an internship with a utility that sells hydropower that comes off of federal dams. So that's really where I first got interested. In that internship, they love to show off the dams, the major civil assets of their infrastructure, but I was more focused on the power side and the transmission that was coming out of those facilities. So that's where I learned how big of industry this is and what a major part civil engineers can do. Fast forward, I've now been with Burns McDonnell for 12 years, all doing transmission line design, and been fortunate to be able to serve a lot of major IOUs across the country, as well as some more local utilities, ranging from all voltages, and really got quite a bit of experience in all types of transmission structures, but primarily steel poles and lattice towers, which we're going to talk about more today.
Wonderful. I love it. And Brandon, you are not the first guest on this show to say it all started on a farm. So I appreciate the context there. It's great to hear a little bit more about your background. Zach, how about you?
Yeah, I'm very similar to Brandon, also agricultural background. So there's another one for you. And I knew going into college, I wanted to do something with math, problem solving, didn't really know what. I actually ended up switching majors 2 times throughout college. Ended up on civil engineering, again, with that, glorious bridge in mind. I interned at a DOT, and then I eventually applied at Burns McDonnell, not really knowing what I wanted to do, but knowing they do all kinds of things. I was lucky enough to get a call from the transmission and distribution department, went in for an interview, And I actually poke a little fun at myself. When I was on my pre-interview, I went out to lunch with a couple newer engineers at Burns and McDonnell, just kind of introductions. And they informed me I was interviewing for the overhead department. And in my mind, I was thinking I'd not apply for HR or people management. It must be some kind of mix up. But I went with the flow. Eventually found out they meant physically over your head as opposed to, substation underground lines. So that was my introduction to transmission industry. It's been 12 years since then. Couldn't be luckier or happier. As far as the projects at Burns McDonnell, as of lately, I've been geared more towards EPC projects, which means we design them, procure them, and ultimately construct them through a subcontractor. So I get to see, all stages of the projects, including construction, also looking for ways to be as efficient and economical as possible.
Yeah, I love it. And I love getting the inside scoop there on pre-day one, what exactly it was like. Would have been in a very similar position myself. So thank you so much, Zach. So as we dig into this conversation of the lattice versus steel pole, that's really what we're after today. That's the conversation that we're going to have. I would love to start with just kind of getting the baseline understanding of why this is a question in the first place. So if you guys don't mind, could you give me a little bit of the rundown of this lattice versus steel pole? Walk me through each side and kind of what it represents in terms of opportunities, challenges, and who wants what in this utility industry.
Absolutely. So I think the best way to look at this is kind of look at the history of the transmission build out in the United States. I mean, if we really think back to most of our grid was built in the mid 1900s, right? And in that day, lattice towers were very popular. They were easy to fabricate, easy to assemble. And steel poles kind of took hold in the back half of the 1900s as technology developed that allowed them to be manufactured. So we got, more advanced welding techniques. We got ways to bend thicker steels, et cetera. All of these manufacturing techniques really allowed for steel poles to take hold. But by the time that happened, the major growth in the United States for the transmission system, wasn't like it was in the mid 1900s. So we fast forward to today. We've had minimal growth these last decades, and now we are seeing increased power demand more than ever. We're seeing the need for these increased extra high voltage, long distance lines to move the most amount of power we can with using the least amount of right of way. So as we talk about these mega lines again in the US, which again, we haven't talked about in a big way for several decades, we got to look at ways to structurally support those. And really we start to bridge the limits of what steel poles can offer and have to go back to these larger footprint towers, that were introduced in the United States and widely used in the early 1900s. So we're kind of back to the drawing table again.
Yeah, I think it's this idea of timing is really interesting. We're talking about an aging grid. I think the stat is something like 50% of the grid was built, or 75% of the grid was built 50 years ago or more. When we're talking about the need for transmission, this idea that it might be time to revisit what it took to do that initial grid build out is a really compelling and interesting part of the conversation. I think it would be helpful to kind of illustrate why transmission is so important right now, just so we make sure we really have the table stakes set. It seems like this idea of, lattice to steel pole was a trend that was headed in one direction, and now we might be headed back in the other. Why does it suddenly feel so important again? Can you contextualize or put into context, what it means for us to have such significant need for high voltage transmission right now?
I guess in my mind, it goes to, there's everybody in the country knows what the data centers at this point. 10 years ago, it wasn't really heard of. They take tons of energy. There's also big solar farm, wind farms going up around the country to power those. So more and more power going longer and longer distances. You need higher voltages to get it there, cranking as many amps as possible through those lines. But just really, all those come together to really increase the loading requirements on these transmission lines that we're seeing more and more every day, as opposed to 10 or 20 years ago.
I would say just outside of data centers, like there's so much other electrification going on in the United States. Obviously we know the vehicle electrification is a big thing, but something else that's going on, especially in the Texas area, is that we're electrifying the oil rigs. So that is a huge project right now, and ERCOT is dealing with that. It's causing them to push the 765, the extra high voltage projects forward to electrify these oil rigs. So it's not just about data centers, not just about electric cars. It goes beyond that.
So I would love to understand a little bit more how the team at Burns and McDonnell is thinking about the difference between these two. We have started to dig into some of the comparisons, but I'm curious to know a little bit of the process when you guys internally are trying to look at one versus the other. What does that look like?
Absolutely. So Zach and I recently had the opportunity to dive into this a little bit more to develop a presentation for what we call the Transmission Symposium. And this is an event where we bring in our clients and we present with them, different topics that are impacting our industry. So Zach and I were really interested in where is the tipping point of lattice towers being more cost efficient than steel poles. So what we did was we came up with a study and we took existing lattice tower designs that were designed in the 1960s to 1980s timeframe. These are towers that are still used in new construction today. Therefore, we know their weight, we know their cost, we know their lead times, and we're really able to use that as a good baseline. So what we did was we took those existing designs, we knew the geometry, we knew the loading of those lattice towers, and we looked at what an equivalent steel pole would be. So we used a feature within PLS pole called the pole optimizer function to see what those poles would weigh. And from there, we were able to, compare the steel weights of towers to poles, but we were also able to do detailed foundation design and see how that all comes together for a, total all-in installed cost.
Yeah, and to add on to that, we looked at voltages from double circuit 138 kV. I think we included a double circuit 230 kV and then 345 kV. And we looked at tangents and dead ends for each of those in 3 different heights for each one. So we had about 18 or so data points to do this. So we had a tower and the equivalent steel pole. We knew the tower weight, like Brandon mentioned. We used some PLS pole hard software to estimate the equivalent steel pole weights. And then we did foundation designs using some subsurface assumptions and things like that. So I guess the big thing to keep in mind is we assumed, equal access cost. And we're really just trying to see, under the same loading, same span length, same conductor type, how does that impact the cost between the two?
Across the board, we saw that the towers were more cost effective than steel poles. However, I think it's important that we revisit our initial assumptions. So we did start with a double circuit 138 kV design, and that's really, a heavily loaded structure. I think if we would have started with a single circuit 138 or maybe even single circuit 230, we would have seen the steel poles be more cost effective than towers. So I don't know that we really went far enough down the loading to be able to see where that inflection point happens in cost.
And to add on to that, I think the span length for these were about 1,000 feet. So these were towers designed for 2 circuits with pretty long spans. And that's really the lowest we went because, anything less than that, I think it kind of proves that steel poles typically have the advantage. Because if towers were cheaper, there'd be a lot of towers, 69 kV voltage type towers. But really the most common towers that we were able to find used consistently today was 138 kV and up with pretty long spans. So that's kind of an interesting point. And the 138 kV double circuit structures, I think on those, the steel poles and towers were very, very similar in cost when looking at the cost of the structure plus labor plus the foundation. And then as we went up from there, the steel pole costs increased exponentially compared to the lattice tower equivalent. So I would expect anything less than that, we kind of start to see the steel poles start to be more favorable.
Absolutely. Now, I understand that a lot of system design kinds of decisions for utilities are also, as any decision is at a utility, a question of cost too. So can you give me a little bit more insight into the cost comparison for these two when we're looking at the options for this next generation of build out, lattice versus steel pole? How do the costs stack up?
I think a lot of it comes down to, looking at what a utility values. So we can do all the math we want. We can design the structures. We can design the foundations. There's so many variables that come into play here. Obviously anything we have to design has to be constructed if it's going to hold value. A utility wants to be able to operate these. That's how they make income, correct? They're pushing power down the lines through these assets. So it really comes in to, more than just the steel, and the concrete that go into these. So there's a ton that utilities are considering as they make these decisions. But I think something else that, is kind of driving the industry and has really driven the industry towards steel poles in the last few decades is as engineers and utilities, we're always looking for the easy button. What is easy for us to design? And the steel pole industry has been great in the United States. It has massive build out. We have many suppliers. These suppliers have domestic engineering support and fabrication support. They have partnerships with these utilities. They really have made it easy for these utilities to use their products. And because of that, we've really seen it drive towards the steel pole industry. And kind of on the flip side, we've seen Lattice towers recede in the United States in particular. There's just very few major manufacturers left in the US. Pretty much everything that we're getting today is coming from overseas or another country, which just introduces more challenges, especially from the engineering and procurement side. So a lot of different factors that people are looking through as they make these decisions.
Also, when deciding to use lattice towers versus steel poles, they have to think big scale system design kind of. For example, a lattice tower takes a lot more design time and a little bit more of a learning curve on the design and construction phases, to where it might not make sense to use a lattice tower for a 2-mile, double circuit 345 line if a utility does not have a standard in place already for that. Just because you might save a little bit of money per structure, but the amount of design time and the learning curve for those construction crews and stuff, all for 10 total towers, probably isn't worth it. On the flip side, if these utilities are going to start developing standard tower families they can use again and again and again across projects, maybe form working relationships with construction crews that either know towers or is willing to learn them over the course of a few years, that can really start to have an advantage, for the long term. Same can be said for a single very large mega scale project. If you have a 200-mile, 500 kV project, that learning curve and upfront design time is worth it just due to the scale of that one single project. But for a one-off, very small project, it doesn't really make sense to use towers for that one project and not use them anywhere else.
Yeah, I think that kind of goes back to the history that I was talking about. These last few decades, we've really been focused on connecting new infrastructure to the grid, not expanding the grid itself. And that's where these small projects that Zach mentioned, have been very commonplace the past few decades. And looking ahead, we're seeing stuff all the time that we're talking about multiple hundreds of miles of line being built, totally different than what we've been doing in the United States the last few decades, and does change the way we can look at this.
Yeah, they call it unprecedented for a reason, right? So you guys have mentioned a couple big ones here: cost, design time, supply chain, standardization. As you both have worked to study this comparison between lattice and steel poles more deeply, I'm curious if there are any other elements of the comparison that we should hit on or dive a little bit deeper into. What kind of assumptions are you making when you're studying these? What factors matter the most? Can you tell me a little bit more about how you compare the two on your teams?
Ultimately, we are working for utilities, our clients. They come into these projects, and a lot of times they have a preference of what they want, and that's based on what they're comfortable with. So there are projects where we have the ability to kind of drive that decision a little bit. And where we do, we can look at access on it. We can look at the current market conditions. Lead times becoming a huge issue in the industry right now. So as more and more product is needed, steel pole lead time has gone up substantially over the last few years. So just seeing how all that comes to play and how the client wants the product.
Not really. I guess kind of this big picture. Anytime you do some kind of cost comparison study or something, there's so many variables that go into that. You have span length, access considerations, conductor size. Do you want to go, smallest conductor and limit loadings, or bigger conductor, heavier loads but less line losses? More return on your investment for the service life of the line. It's more than just like a one-to-one comparison. There's a lot that can go into that, more than just structure types alone. There's a whole lot of variables. It's kind of hard to narrow down to the ones that really matter sometimes.
Yeah, I think that, Zach, this is a good moment to talk a little bit more about some of the realities of construction when we're talking about this question as well. So when you're looking at, projects on the ground, trying to really make traction, make moves happen here, have you found that construction leans in one way or the other in terms of pushing for either lattice or steel pole? What kind of is the paradigm of that back and forth?
Yes. I think like most people, everybody has they like to stick with what they're comfortable with. That goes for construction crews also. In this day and age, most crews have a lot of experience in steel pole construction and very little in lattice towers. There are exceptions out there, some crews that do specialize in lattice towers and are very good at that. I would say any crew will do the work, but if you ever go out for pricing or something, it'll become very apparent at that point what that crew wants to do. If you go out, for a side-by-side steel pole versus lattice tower pricing sheet, um, the cost to get back will be very indicative of what those construction crews prefer and are, willing to work with.
And what about something like outage windows? I'm curious to hear how that might impact the economics of a project like this, or the decision making calculus of a project like this. Can you tell me a little bit more about what the two kind of bring to the table when we're looking at potential outages?
Absolutely. So I think, one of the biggest problems in our industry right now is we can't build capacity fast enough to keep up with our rapid demand growth. So this is putting an extreme amount of strain on the grid. And because of that, grid operators are really limiting the outages that they're going to allow us to take on the existing infrastructure that's out there. So recently I worked on a 345 kV rebuild project, double circuit 345. And going into it, the client wanted to use lattice towers. That's what was out there. That's what they wanted to go back with. They have the capacity. We know they were more cost efficient for this use. However, it became a reality that the outage window that they were going to get to do this work was going to be so small that it was going to take a long time for them to be able to fit in enough hours to get the work done. So as a result of that, we went back to the drawing table and we looked at, hey, what does this look like if we go with a vertical double circuit steel pole option where we can offset to one side of the right of way. We keep the same right of way that's there, but just have a narrower footprint and come back in. And ultimately we went with that. We had the design for the lattice tower done. We did the design for the steel pole. We knew the lattice tower design, just looking at steel and concrete, was significantly cheaper than the steel pole option. But the fact of being able to get it built in time, really drove us to going with the steel pole option in that case. So ultimately the utility could get their asset built and get the return started faster.
Yeah, that's a great example. I think this is one of those conversations that I feel like once you start asking about, okay, and what about this, and what about this, and what about this, it's a little bit of a can of worms here. But I've got another one. When we're talking about some of the considerations in this larger question of lattice versus steel pole, we have talked about some of the big ones. Another one that I'm curious about is just terrain in general, access in general. Obviously, this is a big part of, number one, ensuring reliability, limiting outages, but number two, also construction and crews and how they're perceiving this question itself, which we've already touched on. So tell me a little bit about how you see terrain and access in general potentially changing what might be the optimal answer or the plan A for projects of this nature.
Yeah, so as you mentioned, access costs are a huge component. And there's actually a joke in the industry that most transmission projects are really an access road project with a transmission component. I've seen projects where access costs are over half the overall project cost. It's ridiculous. Especially when you get in these hilly, mountainous regions. Lattice towers, you can bring in piece by piece. You can fly in with helicopters. And there's ways to get those on site with little to no access improvements. Whereas steel poles, getting a 50-foot, 20,000-pound steel section up the side of a mountain can be very costly to do. So access costs definitely need to be considered. The impacts obviously vary by what region you're in. If you're in flat Kansas through farm fields, putting gravel access roads down, it's going to probably be a wash between the two. But once you get into those hilly regions and stuff, then towers really start to become more ideal compared to steel poles.
And that really goes back to the fact that towers are simple angle members, but they can be broken down into small chunks. They can be built in sections and easily flown in. Steel poles, especially when we start talking extra high voltage, we start to get a lot of weight in steel there that may not be an option to fly in. Or if we need to get it in via an access road, we have to substantially build up that access road to be able to get cranes and equipment into site. So like Zach said, certain terrain can impact just the ease of getting the material to site.
I'll say, and theoretically, you could start to limit your pole sections to be, 10, 15, 20 feet long. But at that point, you're putting so many pole sections together. The slip joint overlaps or flange connections are the most costly part of those poles, so you start adding those up quickly. So the steel poles start to inflate in cost even exponentially at that point.
Yeah. I think as we're having this conversation, one of my big takeaways here is that I am not envious of the people who do have to make these decisions. It feels like there are so many different inputs and considerations to make when you're trying to figure out what works best for the very unique situation that you're in. I always am talking about how two utilities are the same on this show, and it seems like no two transmission projects are the same as well. If we had to, though, I'm curious to push the two of you to see if there are, a situation to kind of wrap all of this in a bow, a situation or situations in which one makes more sense than the other. If you had to give us a real world example or point to something that you think is emblematic or illustrative of when one works and the other doesn't, I would love to hear what your thoughts are. Where does each of these thrive?
Yeah, so I've seen, I think we're all aware of, there's a lot of low voltage single circuit steel poles out there today. I kind of personally draw the line. I've seen recently a lot of single circuit 345 kV lines on steel monopoles with brace posts and guide dead ends. I think that's kind of the spot where steel poles can shine. With the brace posts, you can get pretty compact on your face spacing. The guide wires really reduce your foundation sizes. I would say from that point, anything below that, assuming access is reasonable, steel monopoles start to make sense. I've also seen voltages as low as 34.5 kV use lattice towers, again, because they were in the mountains of West Virginia. And just from an access standpoint, it made way more sense. I would say probably double circuit 345 to 500, definitely 765 kV. In those instances, really regardless of terrain, I would expect lattice towers to kind of start to be the more economical option. Now, I could be wrong. I'm sure there's examples where that's not true, but for the most part, that's kind of why I would draw the line personally.
I think something else to look at is also just the area you're in. So if you're in a rural environment, like lattice towers probably make sense, especially on these higher voltage lines. As you get into a more urban area where you're constricted in the footprint you have, the right of way limits, etc., it really starts to make more sense to do steel poles because you can easily customize them to do funky angles or to have one-off taps, switches, all of that stuff. That's a little harder on a tower. So if you think of a tower as we're essentially making a building block and then applying that building block time and time again. That's where towers shine. So these 100, 200 mile lines that we're building across the United States, those make a lot of sense for towers.
Yeah, definitely. It brings up, I think, an interesting question about this shift in demand that Brandon, you mentioned at the very beginning of this conversation that, lattice towers were potentially the simpler, easier choice when most of the grid was being built out, 75 plus years ago. If the demand rises again now, given the transmission needs that we're currently facing, given that unprecedented demand, how do you think that could change potentially pricing for something like lattice towers and supply chain too? What about the realities of putting these on the ground changes if demand starts to kind of climb back up?
Absolutely. Supply chain is such a tricky question these days. Like it's ever changing. Demand is so high. We're seeing lead times go up on everything. But I think something to look at here is although the US doesn't have much lattice tower production domestically, it's not that advanced a technology, right? It's basically taking steel members that are produced elsewhere, bringing them in, punching holes, cutting them, and then sending them out to site. It's very easy fabrication. I think as the demand increases, we are going to see some shops come back onshore, but these shops are not that advanced that they can be brought up to speed in production relatively quickly compared to steel poles where we have the advanced welding, the advanced bending that's going to take place. That's going to take longer for them to ramp up production. I think another thing to add there is as a whole, like the United States has really trended towards steel poles, but if we look worldwide, like lattice is still used in other countries. The production is still out there. The expertise is still there, just not so much in the US.
Certainly makes a lot of sense. And I think there's a kind of a question at the bottom of all of this back and forth that we've been talking about today, which is what is the best way to decide. We've gone through a lot of these comparisons. We've gotten a better understanding of where one makes sense versus the other. But if a utility leader were to ask you point blank, how do I choose? What would be your simplest advice, your simplest answer?
I don't know if there's a simple answer, unfortunately. I mean, do your homework. It really depends on where your region is. I would just say, don't leave any rock unturned. Think about all the inputs and things that are impacted by this decision. We talked about, terrain, construction, is a labor available, lead times, outage constraints. Also, I mean, it also comes down to your inspection and maintenance procedures as well. Do you want to, change those up if you're so familiar with steel poles? Adding one tower line on your entire system might, throw a wrench in your typical maintenance plans. We have to come up with a whole new set of plans just for that one single line. So there's a lot of stuff to consider. Don't just focus on, material cost only or upfront cost only. There's a whole lot more than that. That's more than one sentence, but that's really what it boils down to.
Something to add there, Zach, that you kind of touched on is, at the end of the day, utilities have to maintain these lines. And we do get severe events. Lines do go down no matter how well we design a line. A tornado, hurricane, whatever the severe event is, will take it down at some point, or agricultural impact. Utilities have to be ready to mobilize and repair. And one of the things with Lattice towers that's kind of unique is they can order these, they can store them really compact. So a lot of times Lattice towers, especially if it's coming from overseas, will come in a shipping container, just a bunch of steel stacked together. So the utility can have, stacks of these Lattice towers on site and ready to deploy in the need of an emergency.
Yeah, it's like the IKEA furniture of building out.
Exactly, yeah.
Right? Well, you guys, this has been so wonderful to understand the back and forth, the cost comparison, and the many, many other considerations that should be taken into account when utility leaders are making these decisions. If you're down, I would love to get into our lightning round now. We'll have a couple of questions here. We'll keep things quick. If you don't mind keeping your answers to about a sentence or even a word, if you're feeling like it, I would love to pick your brains a little bit more.
Yeah, absolutely.
Cool. So first one, what is your hot take for the power sector in the coming years?
Well, this industry is booming, and really it doesn't appear to be cooling down anytime soon. So it's a great time for people to join an exciting and fast-paced industry.
I mean, I concur. Yeah, it's booming. There's no slowdown coming. We keep thinking, it has to slow down eventually, but it never does. And so someday that might come, but it's not in the foreseeable future at this point in time.
Good time to be in this industry. All right, my second question for you, do you have any recommendations for our listeners who might want to learn more about what we're talking about today? It could be a read, a watch, a person, an article, really anything. What's your recommendation for further research if people are interested?
Yeah, so one of my favorite things to do is get a broad range of information. And I think setting Google alerts is a great way to do that. So you can see news stories from, various parts of the country, various topics, various perspectives. That's really the way I like to get my information.
Yeah, same here. Also, Burns and McDonnell does have some internal marketing updates quarterly that they release. So I like to kind of follow those and stay stay up to date with those kind of documents.
And my final question for the two of you, do you have any quick advice for people who want to build their own career building the grid?
Yeah, just jump in. Don't look back. There's plenty of work to go around, and, it's a fun, dynamic industry to be a part of. We, here in our world, we had interns and new hires to start, and there's so much energy within our group doing this design. There's so much fuel in it all.
And I would say don't let the unknown scare you. None of us went to school for transmission design, so you're not really expected to know anything going into it, but you will learn quickly. And it's a fun and rewarding career to be in.
Yeah, I love that. So much of my job learning has been on the job itself. And I think that's the way it should be. So Brandon, Zach, thank you so much for taking the time to join us on Power Perspectives today. And thank you again to our partners at Burns and McDonnell for making this episode possible. Burns and McDonnell brings together an unmatched team of consultants, engineers, construction professionals, architects, and more to design and build critical infrastructure. Their solutions-driven integrated team offers full service end-to-end capabilities. They leverage industry-leading experience in overhead and underground transmission and distribution and develop tailored, constructible solutions that mitigate risk, control cost and schedule, and advance their shared commitment to a safer, more reliable, and more resilient grid. Founded in 1898 and working from more than 75 offices globally, Burns and McDonnell is 100% employee-owned, and you can head to the show notes, the description of this episode, to get a little bit more information about them. For now, Brandon, Zach, the whole team at Burns and McDonnell, thank you so much for joining me today and for sharing all of this wonderful insight.
Yeah, thanks for having us.
Thank you, Kinsey.
Of course. And thank you to our listeners for tuning in to this episode of Power Perspectives. I'm Kinsey Grant Baker, and I will see you next time.